In this speaking notes episode, I want to show you how to simplify a complex number and how to construct a simple mathematical proof. Now, given that z is equal to x plus iy, which is a non-zero complex number, we want to simplify 1 over z and express it in the form of a plus ib. Now, 1 over z will be equal to, so we put where there is z, we put x plus iy, and multiply both the numerator and the denominator by the complex conjugate of the denominator, which is x plus iy. Now, when we do that, the numerator we have x plus iy, in the denominator we have that multiplication. Now to expand the denominator, you can realize that this is just the difference of two squares. So we can just write x squared minus iy squared, which is just x squared minus, now I squared is -1, so this is plus, then y squared is y squared. So that is why we have x squared plus y squared. Now we are going to split the numerator, so we have x divided by that denominator minus y divided by that denominator, then multiply by I. In the second problem, given that z plus 1 over z is equal to alpha, where alpha is a real number, we want to show that either z is a real number or the magnitude of z is equal to 1. Now we are going to use the result that obtained from 1, that z plus 1 over z is equal to x plus iy, which is z, then plus 1 over z is this expression. Now we are going to factor out I because I is common here and is common in the last expression. So we have x plus, we have x over x squared plus y squared plus. When we factor out I, we have y minus y over x squared plus y squared multiplied by I. Since z plus 1 over z is equal to alpha, where alpha is a real number, then the left hand side is a real number. What I mean is that this expression z plus 1 over z is strictly a real number. Now, if that is the case, then this expression is purely real. What we mean by purely real, it means there is no I in the expression. Now, because there is I, we have to take a note to say a plus bi is purely real if and only if b is equal to 0, so that we just have a here. Now applying that, this implies that this expression here, the coefficient of I is equal to 0. Now we factor out y, so that 1 y onto, so now we factor out y, so that inside we have 1 minus 1 over x squared plus y squared is equal to 0. Now this expression can only be 0 if either y is equal to 0 or 1 over x squared is equal to 0. Now we can just make x squared plus y squared subject to the formula, so that this guy is equal to 0. Now let us pick it from the either here. Either y is equal to 0. So if y is equal to 0, then z is equal to x, because z is equal to x plus iy, where y is 0. So we just have x, which is strictly a real number. Now, if x squared plus y squared is equal to 1, then the magnitude of z, which is given by the square root of x squared plus y squared, is equal to the square root of 1. Why? Because the expression under the root here is 1. So the magnitude of z is 1. Hence, we have proved that under the given condition, either z is real or the magnitude of z is equal to 1. Thank you for watching. Please like, share, and follow. Don't forget to register for the online mathematics competition for first and second year students.